So the next thing we're going to look at is fat, and fat has probably the most demonized of all the macronutrients, and it is the most delicious of all the macronutrients, and rightfully so. It's your body's satiated. Like, fat tastes good. Carbohydrate tastes good, but for a different aspect. And when we look at fat, this includes our animal fats, our nuts and seed oils, and our butters, and anything that's mostly lipid-based. Fat, the term can be misleading. You have fat lipids that are like the food aspect that we look at. And then, as we talked about, we have fat that's the adipose tissue, which are made up of the adipocytes, which are a storage form of the tissues within the body. Regardless if it's the fat, which is basically storage adipocyte from an animal we're eating, or the storage of sugar from the plant that we're eating, like the oil or the nut and the seed, the adipose tissue is the storage site for triglycerides. And triglycerides are a glycerol backbone, which is basically a sugar molecule, carbohydrate molecule, and 3 fatty acids. Fatty acid 1, 2, and 3, that's where 3 comes from for the tri, and that's where the triglyceride is coming from. So as we'll discuss, we can look at these fatty acids, and this is the general structure for the triglyceride. It's a glycerol molecule which can be converted to sugar, and the 3 fatty acids which cannot be converted to sugar. Fatty acids started as carbohydrate at some point, and they were formed either by the plant or the animal to store that extra sugar or fat. And these fatty acids come in a variety of lengths. So you have short chain, long chain, and medium chain fatty acids. Nonetheless, the triglyceride is a storage form of energy, right? It's your near limitless supply of carbohydrate intake. And you look at the chemical structure of the fatty acids, and there are these carbon chains. And so it's 3 fatty acids, and you have a carbon chain glycerol backbone. When you look through here, you can see that there's no double bonds. You can see maybe a double bond right here, and all of these are single bonds. And I'll look at the next slide here. Again, you have your glycerol backbone, you have your carboxyl group, and then you have your fatty acid. And you have single bonds, and you have 1 double bond here. So this is a triglyceride that has 2 saturated fatty acids, and it has 1 unsaturated fatty acid. And the reason why it's unsaturated is that it contains a double bond. And if there's a double bond there, it means that there's not a hydrogen holding it out. And so when you look here at these saturated fats, these are saturated with hydrogen, and this unsaturated fat has the opportunity for it's not saturated, it has potential to take on more hydrogen. So your saturated fats, in this case stearic acid, there's no double bonds, and so it's impenetrable to hydrogen or oxygen, so it's very stable. You have your unsaturated fat, which contains a double bond. In this case, linolenic acid, it has 2 double bonds. So we look back here, there's only 1 double bond here. This is a mono, 1 unsaturated fat. This is a polyunsaturated fat. So when we look at the number of double bonds that are there, that's where you get the monounsaturated fats, and this is where you get your polyunsaturated fats. And we can look at them together here. You have your full saturated fat, fully hydrogenated. You have your monounsaturated fat, which has 1 double bond, and then you have your polyunsaturated fat here. And where this comes into play is the ability of fats to maintain their stability. Fats are reactive to oxygen, and oxygen can react where there's weak links in the chain. When you look at saturated fat, there are no weak links in the chain. It's fully saturated, so there's nowhere for oxygen or any of the reactive oxygen species to react with this. Monounsaturated fat is a little bit more susceptible, but pretty resilient. The more double bonds you have in your fat, the less stable the fat is, the more reactive it is to going bad. And this is why you can take, let's say, butter or bacon fat or any type of animal fat, coconut oil, and you can keep it out, and it's not going to go rancid. It's not going to oxidize. You take olive oil, and you need a little bit more protection from it. You need to keep it in a dark bottle because it's sensitive to light, and you can heat it, but not so much because it will go rancid. And then basically all of your vegetable oils, your corn oil, all of these, they go rancid really quickly. And when we look at the quality of fats, like is it healthy or unhealthy, saturated fat is demonized, and your mono and polyunsaturated fats are held up on a high pedestal. And I argue, based on physiology and science, that this here, because of the stability of it, is actually your healthier fat, and these are your more susceptible. Monounsaturated, not so bad, and polyunsaturated, probably the worst things you can put in your body. And when we look at the evidence, I have thousands of years of human civilization backing me up here, and only about the last 50 years of polyunsaturated fats being available to us. And when we look at our health status today versus all of our degenerative diseases compared to just 100 years ago, much better shape. So there's a couple video resources that I put that you can look at as a tangent, but keep in mind that the only reason why saturated fat has been demonized is because of saturated fats tend to have cholesterol with them, and cholesterol, probably the most misunderstood molecule in this conversation, is attributed to heart disease, when really inflammation and insulin are the pure culprits for that. But anyways, you have your saturated fat, fully hydrogenated, monounsaturated fat, one double bond, and polyunsaturated fat, a couple double bonds. And when we look at this hydrogenation process, and you've probably heard of trans fats or hydrogenated oils, what you're doing is you're taking a cholesterol-free plant oil and you are chemically altering it by adding hydrogen there. So you're adding you're saturating it with hydrogens to get it from a unstable polyunsaturated to a more stable fat. And what they're really doing for this is to give it more texture and mouthfeel. So your like traditionally lards and butters have been used in baking and different aspects, and margarines and corn oil, or at least Crisco, have been used to replace that. And what happens when you do this hydrogenation process is that in a natural unsaturated fat, you have these cis formation where the bonds are on the same side, and in a trans fat, from a chemically altered fat, you have it in this altered aspect. There are only one that I can think of, one naturally occurring trans fat that we get in our diet, and it's conjugated linoleic acid, CLA, and this comes from grass-fed dairy aspects. But most of the fats that we get from this hydrogenated process are these trans fats, and so you get these fats that the body has no idea what to do with. And there's a reason why these have been phased out of the aspect. Now, keep in mind of the history of trans fats. 20 years ago, these were heralded as this was going to cure cardiovascular disease. This was it. Like, if we could replace our saturated animal fats with cholesterol with these trans fats, this was looked at as the ultimate in terms of health. This was the same organizations that were promoting trans fats are now saying these are horrible, right? Cholesterol has the same aspect, where dietary recommendations were don't eat any cholesterol to not, it just, things have changed, and they realize the folly in their thought process. So again, if you look at the same aspect you take with carbohydrate, you look at quality versus quantity, and you look at processed versus unprocessed. If you can eat fats in their most natural, unadulterated state, you're going to be avoiding most of these trans fats and most of these polyunsaturated fats. Because, I mean, think about polyunsaturated fats. These are industrial oils. These are fats that are coming from huge amount of processing. You're taking corn, which I've never eaten a piece of corn and said, oh, this is really greasy or fatty, and they're chemically extracting corn oil from it. You're taking nuts or seeds and you're chemically extracting the seeds from them, versus like olives, where you're just taking an olive and you're squeezing it and oil's coming out of it. Or coconut, and right, there's not a lot of processing that needs to happen from that. So just keep that in mind, that the least processed fats are going to be better for you. The more industrial or processed fats are going to have potentially more consequences. So unlike carbohydrates and like proteins, there are fats that we need to get in our diet. There are essential fats, and fats have function besides energy, right? So carbohydrates only function as fuel. Protein is mostly for tissue repair, and fat is a storage form, but also used in structural components. So there's physiological and anatomical aspects for that. You need just as much fats from calories as you do as protein, but keep in mind that you're going to eat about half as much, because fats are more energy dense, on average 9 calories per gram. So like the 9 essential amino acids, you have essential fatty acids. You only have 2 of them. There's about 20 to 25 different types of fatty acids, and we need 2. We need omega-3 fatty acids, and we need omega-6 fatty acids. Now, these are polyunsaturated fats. And what happens with the omega-3 is that, and there's different types of omega-3, omega-6, omega-9, omega-8, omega-12. There's a whole spectrum. We can make all of them. The ones that we need are omega-3 and omega-6. Omega-3s, they have their first double bond at the 3rd carbon. Omega-6, they have their first double bond at the 6th carbon. And where these fats come from are pretty important. And when we look at the omega-3 fatty acids, you have short-chained, and you have medium chained, and you have long chain fatty acids. And same thing here, you have short chain, medium chain, and long chain fatty acids. And why that's important is some of these fatty acids you can get from plant sources. So like your shorter chain fatty acid you're going to get from flax seeds. Some of these need to come from animal sources like grass-fed animals or from fish. Now fish themselves do not make these fatty acids. They get them from their diet. They just happen to convert them from these short chain fatty acids to these long chain fatty acids. In some humans, we can take the short chain fatty acids and get them in our diet and convert them. Now when you look at the sources of omega-3 and omega-6, if you look at the list here, you can see that grass and algae, so chlorophyll-based plants, are the largest source of omega-3 in our diet. But you're thinking to yourself right now is like, I can't eat grass, and algae, I'm not interested in eating algae. You can see that a little bit in chia seeds, walnuts, and flax seeds, and that's about it. When you look at your omega-6 sources, you're seeing more of the storage form. So omega-3 are more your growth form. So these are going to be your green sources, so that you find in the spring and summer for rapid growth and development. And omega-6 are going to be your plant versions of your storage, like when the fall and winter comes and you start to go to seed and storage aspect. And so this is where you get this predominance of nuts, seeds, and grains, particularly in our aspect, corn and soy, which are some of the highest sources of our food stocks because of the processing and farming. We get a huge amount of omega-6 fatty acids from that. So when we look at omega-3 versus omega-6, they are opposite physiological function. They're like yin and yang. And for example, omega-3 is anti-inflammatory, whereas omega-6 is pro-inflammatory. Omega-3 is involved in blood thinning, whereas omega-6 is involved in blood clotting. So they have opposite physiological function, and it's okay because we need these more in a 1-to-1 ratio. So that's the idea, is to have these fats consumed in a 1-to-1 ratio. Unfortunately, most of our standard American diet now, these are as bad, good on good end is 1-to-27 and can be as off as 1-to-64. So when you look at your fat strategies, you want to figure out ways that you can minimize your omega-6 intake and maximize your omega-3 intake. And when you look at the list over there, you're going to cut out grains and seeds and especially your processed vegetable oils. But now how do you increase your omega-3? And without relying on supplements, you look at grass and algae as your biggest source of that. Even the flax seeds and the chia seeds and the walnuts, their ratios are like 4-to-1. You have 4 times of omega-6 as you need omega-3. Chia seeds, I think, are the only seeds that have a higher omega-3, but you need to eat so much of it that you're not able to reduce your omega-6 intake. And so this is where the popularity have been like wild-caught salmon, grass-fed beef, free-range chickens, and pasture-raised dairy, is because this is how we ate our animal products for century. And it wasn't until the last like 30 or 40 years that we've been really using grains as a way to fatten up our animals, right? Maybe in the last 50 to 60 years. And so that's relatively new to our livestock. For the most part, whenever we ate animal products, they were naturally grass-fed, right? Grains can be fed to humans, so why would we feed the grains to the animals but grass, people spend all this time cutting their grass when all that can go to the animal, right? So these were things that the animals were able to eat. They didn't compete with our food sources. So chickens ate mostly bugs. They eat everything. But ruminant animals like cattle and like sheep, lamb, and goat and cow, they eat grass. And then we in turn, they convert that into edible aspects and we eat that. But as they're eating the grass, they are intaking huge amount of omega-3 fats, and they are storing those in their tissues. And then when we eat that animal and that fat, we get our omega-3 from that. So same thing with salmon. If you get salmon and it's farmed raised and it was fed food pellets, those food pellets are going to be mostly omega-6 fats. And so you're under this illusion that the fish has this naturally occurring omega-3 only if it's wild caught, only if it's eating algae. So that's what we look at when we look at quality of fats. We're not looking at is it saturated or unsaturated. That's the old way, and that's a very incomplete way. We want to look at the quality of the fats. Are they saturated in terms of are they natural? Because if you have an unnatural saturated fat, that's basically a trans fat, that's horrible for you. If you have an unnatural, like a chemically industrial oil like Crisco or corn oil, it's gonna have consequences to it. But if you eat things like butter or naturally occurring grass-fed pasture-raised lard or beef tallow, probably going to be just fine. It's going to taste great, and it's probably going to be more protective because of the anti-inflammatory nature of the omega-3s there, not the pro-inflammatory of the omega-6 or the reaction that's occurring within those blood vessels for the damage to the lumen leading to the cardiovascular disease. So lots to research, different perspective. Keep in mind that saturated fats may be the best thing for you, and that you want to look at your omega-3 to omega-6 ratio when you're trying to look at good fats versus bad fats.